Okay, let's get started. Hello, everybody, to the Gardener review meeting. We will talk about the 1.45 release, and we have 6 topics. We will start with radar and the PVC autoscaler now becoming a seed cluster component. Then we have Alexander with a few features for the fiber extension and some advanced configuration options. Next up would be Kevin with the dual stack and custom route table support in the AliCloud extension. Then Johannes will talk about the migration towards machine capabilities and the provider extensions. Then Martin talks about the Shoot DNS service extension, and here we have the migration to the next generation controller. And finally, Tim will share a new helper script that can rebootstrap a failing Gardenlet. Okay, with this, Radha, please get started with the first topic.
Yep. Do you see my screen now?
Yep.
Yep, perfect. So I'm sure most of you are pretty much already introduced to the PVC autoscaler and what we intend to do with it. We intend to use it for our observability stack mainly. And this PR introduces the PVC autoscaler as a seed cluster component. This volume claim autoscaler is what we agreed upon during the TSC process. So for now, it is defaulted to false. And when further integrations with the observability stack are finally done, which is, by the way, another PR which is underway as well, this will most probably be changed. The PVC autoscaler currently fetches metrics from Prometheus cache, and I can show you just a quick demo. Here we have a seed on my remote setup, and then you can see the persistent volume claim autoscaler, usually defaulted to false. Then we're gonna enable it. We should get a reconcile in, and then here we're watching the deployment as it's getting deployed. So one thing is we can check the logs. Here it's gonna start getting the leases and everything. Then I'm gonna apply a dummy persistent volume claim autoscaler, a pod with a persistent volume claim, nothing really. And it's just really getting a bunch of resources and it's wasting a bunch of storage. So we're gonna check the logs. It's gonna take a bit of time, most probably. Okay, for it to catch on. But yeah, it's gonna scrape the Prometheus cache, as I said earlier. So it's configured, and that's likely the way it's gonna happen. That's why I chose the name to match Valley, for example. That's how it's gonna happen for the observability stack. So now we're gonna see we have the used space logs, and then we have the event of the resizing storage from 10 gigabytes to 11. And I think that's all from me for the demo. If you want to follow our plan, we have this recorded in an issue, and you can see how we're going with the actual integration with Gardener, not just the development of PVC autoscaler.
All right, super. Any questions or feedback? Nope.
Can it also support the etcd PV?
currently, no. This was not a goal of the TSC, but it could potentially be looked into. Let's make it more stable, and then we're gonna take a look at it.
I think there was a specific issue that mentioned that autoscaling of HCD PVs is out of scope anyways.
Yeah.
I think that it's even part of the HCD Druid's goals. I'm not sure about the details, but I think this was mostly decided before we started implementing the integration. So
that's why it's not really in the scope of at least this gap. So
for HCD, the volume support it's a quorum sensitive workload. So HCD Druid already knows and understands quorum. So that's the reason why that comment was made. And we wanted to pursue that further as a responsibility of HCD Druid.
But in general, does HCD benefit from autoscaling? It has hard limit of 8 gigabytes for the disk, so why would one want to autoscale it when you have this fixed size requirement? Except IOPS, I would say.
Exactly. IOPS is one of the reasons.
Any other questions?
Can't we start with a lower disk size for HCD if we had this auto scaling to start with? Won't that help? Like 1 gig HCDs don't need to have bigger volumes reserved for them.
That is right, because for when we did these analysis over all the live clusters and Candy clusters, we found that around more than 80% of our HCD clusters are somewhere less than 3 GB. So having a very large volume size for them is kind of a waste of money.
Yeah, and that's also a goal of the PVC autoscaler as well, but it's just for the observability stack. That's why something I forgot to mention, we're also trying to match ourselves to the rollout of Victoria logs. So it should be also nice and simple, hopefully. And then this way we could deploy the monitoring stack with smaller PVCs to begin with, because it's going to be harder to introduce it on already big PVCs since we don't support scale down. And that's it. Any other questions?
Nope. Then thanks again. And let's move on with Alexander and the advanced FICO options.
Hello, let me just share my screen. Okay, so you should be able to see now. So I'll present some features we added with the new Falco release. So the first one I'll present is a new destination for Falco events, Pong. It is configured the same way our previous destinations were, with simply a secret ref with the required fields for the Splunk configuration. The Splunk configuration fields are the same that would be in Falco Sidekick, since we do use Falco Sidekick for exporting Falco events. And if we also see here in the Falco Sidekick documentation, we can also find the Splunk fields right here. Let me just return there. Yes, we also have a documentation here what these fields are and what do you need to configure. I have such configuration in my local shoot. If we if we just get the shoot, my autocomplete it's a bit slow. Let me just copy the command from previously. Okay, let me get it. So you can see here we have configured the Splunk output. We also have the secret that is something like this. And with this, we push events to Splunk. Let me just generate some events with a pod I have configured that would generate Splunk events. Let me see if okay, I'll just apply it. Oh, I actually have the pod. I just wrote the default wrong. Yeah, let me delete it. Pod. So apply it. And now we'll get the Falco Sidekick pods, and we'll have to see the event that it is pushed to Splunk. Yeah, it is being pushed to Splunk. Here's one event. I'll just show it in this place here. This is the Splunk. It takes some time for it to get presented here. Oh, here it is, right from this minute. Okay, let me go to the next PR I want to present. It's about global default destinations. So with this PR, we present a way that operators can configure default destinations for Falco from the extension configuration. This thingy is documented here in the extension config configuration. So the field is global destinations, and here you can just give a name to your destination, the output, for example, output to Woki, and the values are the same as well as the ones that you would configure if you manage Falco Sidekick. And we have also added some template variables that you can use here in your configuration. For example, you can specify the seat ingress domain if the component you want to push is in the seat. You can have service count token that if the component you want to push can authenticate with, for example, the QPAP server or the service count issuer. It can use that, and you have a new thingy, cluster identity token, that is also a new featured PR where Falco can sign some tokens that are cluster specific with cluster information, and you can use that token to authenticate with the system you're exporting to. I have configured such global destination in my local step as well. If we actually see here, yeah, this is the example. It is simply to an echo server on the same shoot as we are testing, and also I have added these three template variables just to see that they work as expected. Let me edit this shoot. Oh, I want to. Let me just do it the other way around, where I edit it here, just because we have some trouble there. And the poet. Connection refused. Yeah, maybe we have some troubles. I'll debug it later. Maybe I can just show you the logs from previous testing. They are in the namespace Falcom echo get pods. Let me just get the logs here. Nice. Let me see if I had them actually from before. Yes, I had not deleted the work. So this was actually the request that was sent to the Echo server, and there in the headers we had saved the seat ingress domain, the service account token, and the other poster identity token that we generated. Yeah, my work was distracting a little bit slower, but that was what I wanted to show you here.
Any feedback so far? Nope. Then we move on. Thanks, Alexander.
Thank you.
Next up is then Kevin with the dual stack and custom route table support in the Ali Cloud extension.
Okay, I will first share my desktop. Okay. Hello everyone. Today I will show two new features for provide Ali Cloud from this 901 PR custom table, row table and dual stack. I have prepared a shoot with this new feature, and the shoot is already running. So we go straight to the demo. First we will check the configuration of the shoot. We can see there are new fields added in the infrastructure configuration. First one is use customer row table true. This gives each shoot its own row table. Without this, multiple shoots in the same VPC will fight over the default row table. With this, each shoot is fully isolated. We can only set this when we create the new shoot and cannot edit it later. And the second config is dual stack enable true. This turns on IPv6. Gartner enable IPv6 on the VPC, creates an IPv6 gateway, and assign IPv6 subnet to each vSwitch. The IPv6 CIDR block number will pick which IPv6 block goes to each zone. If you use a user-provided VPC like this shoot, the number is required. It prevents two shoots from using the same subnet. We can add a dual stack to an existing shoot at any time, but once it's on, we cannot turn it off. Next, let's go to the Ali console to see what happened on the Ali cloud. This VPC is used for our shoot, and we can see the IPv6 CIDR is applied to this VPC, and we can see there are two row tables in the VPC. One is the system row table, the other one is our custom row table. In the custom row table, we can see the default IPv4 entry to net gateway and the default IPv6 entry to IPv6 gateway is listed in the row table, and we also can see our two zone and two vSwitch are also associated with this row table, and each vSwitch has both IPv6 CIDR and IPv6 CIDR. Now let's go to see what the infrastructure of the shoot. We can see row table ID in the provider status. Gartner wrote this to the status, and the system can know which row table is used for the port rows. Now we go to see the dual stack NLB service. I have created a NLB service already. Let's check the config. There are three key allocations in the configuration. One is cater both IPv4 and IPv6 address for this service, and the second IPv6 address type intranet. Intranet makes the IP6 address public, and the last one, the zone map. Zone map tell system which switch is used in each zone. Now we can check the service state. We can see the service is up, and there is external IP that is an NLB service domain name. There, behind the domain name, there are two kinds of IP, IP address, IPv4 and IPv6. We can use NS lookup to check the domain. Let's do it. Now first we can see there are two IPv4 address behind the domain, and we can call again to get the IPv6 address. Now we can, there are two IPv6 domain behind the domain address behind the domain. Okay, that's all my demo. Thanks very much.
Cool, thanks. Thanks for showing this here. Any questions from the audience?
Can you also migrate cluster from single stack to dual stack? Or from IPv4 to dual stack?
No, current the PR is only for only to enable create a dual stack service, and we still not apply the IPv6 to all to the detail of the Gartner platform, such in the Gartner internal, we still use IPv4.
Okay, thank you.
All right, then thanks again. Let's move on. The next topic is the migration towards machine capabilities presented by Johannes.
Yes, thanks for having me. Let me share my screen. Okay. So, first things first, I will share how some provider extension help during the migration to using cloud profiles with machine capabilities, and these are currently the GCP extension, the Azure, the AWS, the OpenStack, and the Ali Cloud extension. Here, shout out to my previous speaker, Kevin, who implemented that feature for Ali Cloud. Thanks for that. And basically, so here's the gap if someone's interested in enhancement gaps 33. But let me open with a little problem statement because the feature is still not widely adopted and will only reach beta soon. Let's imagine we have an OpenStack installation and our cloud profile looks currently a bit like that. We have some OS with a version with a well-known format that defines the version string and the spec machine images type with architectures. And we have also some machines. We have a large machine, which is AMD based. We have a large ARM machine, which is ARM based, and we have a large metal ARM machine. So this machine is not virtualized, but is really a bare metal server that is turned on. And this is why we would like to have a separate operating system flavor that is catered for that kind of machine. And what currently operators had to do was splitting versions up in some kind of form to be able to select the correct flavor for that version. And that would be, of course, for the metal machine, would be the bare metal version image up here. But there was a problem because there was no validation that the actual image would boot with that kind of machine. And also the maintenance, the cluster maintenance had to be turned off because otherwise if a new version arrived, the bare metal tag would be like a pre-release tag in XAMPP, and the machine would have been upgraded to the normal version and would not boot anymore. So this is pretty much the problem statement that we're trying to solve with the machine capabilities. And now let's see how the provider extensions help here with the migration. Looking at the provider config part, this is what changed the most in the extensions. So currently we see also here the machine images field with the matching versions below, the bare metal and also the normal string. And here now the actual image references from the provider are matched against the version string. And to go now to capabilities, we have an easy migration path. So first, we can add the machine capabilities. This part defines which capabilities are available in this cloud profile that we use. It's not global for other cloud profiles, it's just within this cloud profile. And here we can set the architecture, which is pretty much mandatory for machine capabilities. And let's say we set some capabilities that we choose, and we choose to name it hypervisor, and we distinguish between virtual machines and bare metal machines. And this is pretty much all we do. Now let's see how this would look in in the cluster, I have here a local kind cluster with the OpenStack admission installed. And if we apply the first cloud profile, it looks a bit like we know it. Nothing greatly changes. It's just a bit less condensed because the arrays open up. But we have the normal version here. All good so far. Now, if we apply the second example that just added the machine capabilities field, nothing else, we have some convenience features. And these are basically, if we change nothing but adding the machine capabilities, the whole cloud profile switches to best knowledge or to using machine capabilities. And what's happened is we still have in the versions of the OS, we still have the architectures field, the old field, but we also have now the capability flavors populated by the provider extension. And how is this done? Basically, the provider extension knows its format and where the architecture field was previously set, and it reads it out from these fields here, an example of the OpenStack extension, and populates the corresponding flavors. So we can see here the bare metal flavors has only the ARM option, and the normal flavor has two flavors, one for architecture and one for architecture AMD and one for architecture ARM. Okay, now, but what about the hypervisor type that we introduced? So to ease the migration, we basically say, okay, we cannot know currently what these images support from what we know in the extension. So we just say we leave these fields unpopulated, and this pretty much means they are not used when selecting an image. This means we have no benefits from the machine capabilities yet. It's the same security, the same admission as we had before, but it's a way to activate the mechanisms behind and to use the feature, but we don't gain any additional benefits yet. But it's good to test it out. And then we also support, going next, a mixed format. So let's say now we add a new version, and this new version we add now really with the capability format. And how does this look? We have now here a new version 23.00, and this has some more flavors. And here we actually use the hypervisor type. We have the AMD, an AMD flavor that is virtual, an ARM flavor that is virtual, and an ARM flavor that is uses the metal flavor. And also here we don't have to write it in the machine images version part, but this gets also populated from the provider config. And how does this then look in the machine images part in the provider config? Here we have now the new version with a capability flavors field, and here we actually define all the flavors that we have, and these are the exact flavors that we saw above. But the crucial change is now we merged these two flavors pretty much. So the bare metal and the the virtualized flavors are within one version string and are then resolved internally by the extension and Gardener to choose the correct flavor for that machine. So, and if we do that now, we can see the new version will arrive here, and I created and important to know, the old version that was previously there is still in the well-known current and how we call it legacy format. Okay, so we have now a cloud profile that has some provider config that is in the new format, some provider config that is in the old format, but in the non-provider config part, all fields are populated. So the current fields are populated and the capability fields are populated. So automations and scripts reading the API still work as before, as long as they don't read the provider config. But now to an example, I prepared a shoot here that creates two workers. both with the metal ARM machine, and we use the version that is still in the legacy format of the OS. And sorry, where do I have it? Just give me a sec so I don't screw the thingy up here. Okay. And now if we apply it, I just did a try run, but we can see it succeeded because even though we are using machine capabilities yet, as this version is still in the old format and does not specify the hypervisor type, it would still be accepted. So this is what I said. It's nothing gained as long as the versions are still in the old format. But if we go to the next example now, where we could then say, okay, either this version is now deprecated and we remove it, or we will migrate it to capability flavors. And this is what we did now here. We kept the version strings, but we added the capability flavors here. And now we can define that this string actually is bare metal and this version string actually is virtual. And if we now try to apply the shoot again, it will get rejected because now the capabilities are actually used to verify if these images match. And of course, I have to actually apply also the new cloud profile version. So, and if we now apply the demo shoot, it will get rejected because it says that the machine image version is invalid and the capabilities of the machine, bare metal and ARM, are not supported by the Garden Linux version without the bare metal string. And yeah, so this would be a way how operators can step-by-step update their images to the capability format, but don't have the hustle to touch old versions when migrating. And that's for the demo. Thank you all.
Thanks, Johannes. Do we have questions for this topic? Nope. All right. And thanks again. And over to Martin for the migration to the next generation Shoot DNS service controller.
Yeah, hello, good morning. So I want to show you about next generation DNS controller manager. So why do we need a next generation controller? So the main reason is that the DNS controller manager is using a legacy library, the Gardener controller manager library, which is in maintenance mode since many years, and there are not many developers which know the details about it, and it's always a hassle if there are Kubernetes updates or some new features needed. So there was the decision to rewrite the DNS controller manager based on the standard controller runtime library. And yeah, it should have the same behavior as before. So it means the custom resource definitions, DNS provider, DNS entry, and so on are the same. And annotations on the source objects in the shoot clusters, so for service ingress or gateway objects, are also the same. During the rewrite, we thought that there were opportunities for other improvements. So the main major improvement we did additionally was to use authoritative DNS queries on reconciliation. So what does this mean? So if you have a DNS provider, you always have the so-called authoritative DNS server. That's the DNS server which publishes the DNS records, more or less. And normally you don't query this DNS server directly, but you are somewhere down in the DNS server chain and get the query results from there. But you can still also talk directly to this authoritative DNS server. And this has the advantage that you get changes nearly immediately. So that's what we then use on reconciliation to check if our DNS entries are still, or if they need updates, or if they are already have reached the wished state. API calls are only performed on changes, and we have no need for periodic sync of the zone state anymore. This saves lots of API calls, which is especially important on providers with rate limits like AWS Route 53. We only need to fall back to the provider API for private zones because, yeah, if they're private, you cannot talk to the authoritative DNS server from the seat where the controller is running. Or if you are using routing policies, because for routing policies, the returned DNS records are specific to some configuration. So it could be some swap and round or some geolocation or weighted policy. So you don't see all the information you need to check if it's the right configuration. Second point we did was we have now what I call direct DNS entry reconciliation. So there's no separate reconciliation of the zone itself anymore, which simplifies the complete logic in the DNS controller. And then we have also some minor improvements, like we are using a YAML configuration instead of hundreds of CLI flags. And yeah, we use some short caching of the DNS query results to work to avoid repeated DNS queries on reconciliation which happen shortly after each other. Yeah, if you want to see more details, I have here a link for where it's described it a little bit in more details. So the migration for next generation controller happens via the DNS service extension. The motivation is, of course, we want a smooth transition, and this means it must be possible to have a gradual rollout for early feedback before we then finally switch over to the new generation controller at some time in the future. So for the Gartner should users, it should stay all the same, so they should see no difference. And yeah, and as I already said, because of this change with this authoritative DNS queries, we have also the opportunity to reduce the deployment complexity by dropping cache layers. So I want to shortly show how this looks currently and how it looks in the future. So in the old architecture, you have the DNS provider with an API. And on the seed cluster, you have a DNS controller manager running in the shoot DNS service extension namespace. And additionally, you have in each control plane, you have a DNS controller manager which has the source controllers. So if there's now any change to a DNS entry in the control plane, this is handled by the DNS controller manager in the extension namespace, and it goes either directly to the provider, or if you have some additional cache layer. So you could have, for example, in the Gartner runtime cluster, you can have a central DNS proxy, which is a special instance of the DNS controller manager. It goes via this one, so that you reduce the calls to the provider here for read requests. So that's the old deployment. So this the source control in the control plane and site-wide DNS controller manager with caching. In the new architecture, it looks simpler. So you have only the DNS controller manager in the control plane, which directly talks to the providers, and for reading, it normally use DNS queries to the authoritative DNS servers. So here also more details can be found here in this link. So it must be possible to have the old and the new DNS controller manager running on the same seed, so that you can have different controllers per shoot or per seed. So that therefore there are three alternatives to enable the new DNS controller manager. So either per shoot, so you use a special provider config field. It can also be enabled per seed. So this means it's then enabled by default for all shoots on this seed, but you can opt out by setting this use next generation controller to false. And it can also be enabled globally. So that's for the future. If we want to get rid of it, then we can use this global flag in the operator extension for the shoot-DNS extension service itself. The migration is fully reversible. This means if there are any unforeseen issues, you can migrate back shoot cluster by setting this flag, and then after shoot reconciliation, you should have the old status again, as before. Okay, so that was already the short summary, and now I can show a short demo. So here my local setup. I have two shoots in the virtual garden. So both are using still the old DNS controller manager, and I have here some configuration for the shoot-DNS service to add an additional provider, which I will use later. On the seed itself, you have the extension namespace where you have the extension running, and also the DNS controller manager. So that's the legacy one. And in the control planes of the shoots, you have the shoot DNS service deployment. So that's the DNS controller manager with the source controllers. And you have the DNS providers. And as I have already created a service on the shoot, you have also a DNS entry. So this is the service I've already created on the shoot, and you see it has the usual annotations for the shoot DNS service. So the class annotation and the DNS name annotation. Same for the second shoot. So far, so good. And so you also see by default, if you have the legacy controller, these custom resources don't have the annotation DNS Gartner Cloud class because it's the default one. And to enable the coexistence, this is what we use to distinguish it. We'll see it later. Okay, so now let me activate the next generation DNS controller manager for shoot 2. So I've to add this field, use next generation controller. Okay, so wait, a little of reconciliation happens. Okay, I think we are already so far. So you see the shoot DNS service deployment has changed. So if you look
Martin,
at the
maybe
image,
you can finish within the next minute because we have one more topic for today.
Okay, yeah. So you see now it has the next generation, and it has these annotations here, and yeah. So I could show you that it's not using the DNS controller manager in the extension namespace, but yeah. For the time being, I stop here.
Thanks, Martin. Maybe in the interest of time, questions or feedback could be sent via the chat or via Slack so that we can have our final topic for today, the helper script to rebootstrap a Gardenlet presented by Tim.
Yeah, thanks, Raphael. Okay, I'd like to say a few words about this pull request, which adds some useful information for operators and a convenience script. The focus is about manual rebootstrapping. So that means whenever the Gardenlet goes south for whatever reason, for example, the client certificate that it uses in the kubeconfig expired, then you can use that to manually rebootstrap. Manual rebootstrapping means that usually, in the 90% case, I would say you use the operator to deploy the Gardenlet, and you can use the force redeploy annotation to do that automatically, or then it's done by the operator. However, if your Gardenlet is not managed by the Gardener operator because the operator cannot reach the target cluster because of network isolation or any other reasons, then you need this procedure here. So we have already this guide which explains how to deploy the Gardenlet manually, which exactly is for that use case. And there's now a new section calling rebootstrap. First of all, it is explained, the cases are explained again. Then it is pointing to a convenience script that you will show in a minute, that you will see in a minute. But it also explains the steps which are executed by the script and which you can, if you want to, do or follow manually. So what do you need to do if the gardenlet is down because the kubeconfig is not valid anymore? Well, you need to create a new Bootstrap token in the virtual garden cluster. You need to take the existing kubeconfig and paste that token inside the kubeconfig. You can see that here. In the next steps, you need to update the gardenlet configuration so that the gardenlet uses this Bootstrap kubeconfig. And then you need to roll out the changes. And when the gardenlet sees there is a Bootstrap kubeconfig, then it uses it issues itself via a CSR a client certificate-based kubeconfig again. So this is the short version of this guide. But usually you want to use the script that we deliver. So I prepared that in the local setup. Let's look at the gardenlet client certificate first of all. So it was issued before this meeting with the serial number. And this is actually the client certificate that the kubeconfig uses in the gardenlet again. So of course, the gardenlet is running fine here, but let's imagine it's down because of that reason. It expired and we want to rebootstrap it. So what we can do while I execute the script, we watch the secrets in the kube system namespace. We will expect to see a bootstrap token here, and we can watch the gardenlet logs at the same time. Let me do this. Okay, and then we execute the script. So the script is in hack usage. It's called rebootstrap gardenlet.sh. We need the garden kube config, which is for the local setup this path, and we need the seed kube config, which is the garden runtime cluster in this case, and the seed name as well. So let's execute this one. We see that the Bootstrap token is created in the virtual garden cluster. The changes are rolled out. So the kube config is also changed to use this token. Okay, so this is what we looked for. So the restart says there was no kube config. It uses a Bootstrap kube config to request a new one based on a signing request. And the changes rolled out, and the script says that the bootstrap completed successfully, and the gardenlet runs again. Here it's 23 seconds, so it was restarted, of course, or re-rolled out, and we can check the client certificate. Yeah, so it has a different serial number. We also see it here. The time is different, so everything went smooth, and the gardenlet runs again. Thanks. That's it from my side.
Cool. Thanks, Tim. All right, then we are a little bit over time today, but just a minute, so I hope it's fine for everybody. Thanks for coming to this meeting. Thanks to all presenters for showing the demos. And then we meet again in 2 weeks. Have a nice time. Bye-bye.
Bye-bye.
Thank you.
Bye.
Bye-bye. Thank you.